Hi, I'm Dr. Jackie White from St. Leo University, and today I have Tally with me. We're going to be looking at critical thinking. How can we use common sense and critical thinking to analyze different statistical results in statistical studies? So what we're going to do is begin looking at some of those different types of statistical studies or different ways that you can get samples, and what some of the problems are with those that we need to think critically about. So let's go ahead and take a look at our first type of bad sample. What we have is a voluntary response sample, or self-selected sample. It's one in which the respondents themselves decide whether to be included. Have you ever gotten like some kind of survey, either internet or radio or in the mail or something like that?
Yeah.
Well, what type? Well,
I got one last month about some kind of radio survey.
Okay.
Yeah.
And did you call in?
No.
And that's an example of a voluntary response, because if it's a radio survey, first of all, you're only reaching the people who are listening to that particular station. Not only that, but then you're also only going to get responses from the people who are near a phone or it's convenient to call, as well as the fact that if you don't feel strongly about something, you likely will not respond. And usually, to feel strongly, it's a negative feeling. And so you're getting a very, very skewed result there when you're using a radio survey. And the same thing would be true whether it's in the mail. You need to have an address. There's all different types of things that would restrict or limit the respondents to those particular types of surveys. Another problem you might encounter is small samples. Conclusions should not be based on samples that are far too small. An example of that would be the Children's Defense Fund. They published something called Children Out of School in America. What they said was that out of children who had been suspended in one region, 67% of those that were suspended, they were suspended at least 3 times. Now, to me, that sounds outrageous. But then it ends up that there were only 3 children in that region that they were surveying. So if you're looking at 3 children, 2/3 of that means only 2 kids. Well, unfortunately, 2 kids should not be suspended more than 2 times. But anyway, that's still a very small number, and that cannot give you realistic results when you're based on a number that small. Let's go on to another type. What we also have is graphs. Graphs are often used because they're a quick visual image, such as the bar graphs and pie charts. They can be used, though, to exaggerate or to understate the true nature of data. A real common issue with graphs is having the scales not start at 0. For instance, if you wanted to show a really drastic difference at the top of a scale, or the top of a chart, then you'd cut off the whole bottom and just show the top, and that would exaggerate it. So what you want to do with graphs is really look at the numerical values illustrated in the graph rather than the picture of the graph itself, and make your decisions and understandings that way, rather than that quick visual image that they're trying to imprint upon you. Similar to that would be pictographs, which are drawings of objects. They may also be misleading. A real common one there would be when you use a picture, let's say a money bag to represent a certain amount of money. Well, if you wanted to double that, that would mean that you would just make it twice as wide or twice as tall or twice as deep. However, it's very common for that money bag to suddenly become all 3, twice as wide, twice as tall, and twice as deep, which is actually 8 times the original amount. And of course, that looks a lot bigger than just twice the original amount. So that would be a common misleading aspect of pictographs. Moving on to that, let's take a look at percentages. Percentages can be interpreted many different ways, and actually people aren't real comfortable with percentages, so that can be misleading or unclear. Percentages are sometimes used. In other words, if you're taking 100% of a quantity, really it should mean that you're taking all of it, and you shouldn't try and trick people with that 100% idea. An example of that would be Continental Airlines had advertised that with their lost baggage, they had that was an area where they've already improved 100% in the last 6 months. Well, does that mean that in the last 6 months they haven't lost any bags? I don't think that's what they mean, but that's a case where the 100 percentile is kind of misleading in that particular example. What I'd like to do now is maybe take a little time to talk about percentages. I think a lot of people need practice with their different percentages. So what I'd like to do is look at this particular example, and then we're going to pause for a minute, and Tally's going to work on this, and you might want to work on it at home as well in order to practice a little bit of the percentages before we move on to some other types of misleading samples. So in this case, it says that in a Gallup poll, 52% of 1,038 surveyed adults said that secondhand smoke is very harmful. What is the actual number of adults who said that secondhand smoke is very harmful? Now that's the one that I would expect that you'll work on, and I'm going to put this back in just a minute. But in addition to that, as soon as Tally finishes that and we go over it, I'm going to work on this one. So if you have extra time and want to write them both down, you could try them both. It says that among the same 1,038 surveyed adults, This time we have that 52 said that secondhand smoke is not at all harmful. What we want to know this time is what is the percentage of people who chose not at all harmful. So in other words, 52 is what percent of 1,038. So that's going to be the second one. But what I'd like you to do right now is pause your video and try this first one. Then Tally's going to explain the answer to us when we come back. Well, I think, Tally, you finished this problem, so let's go ahead and you can explain your answer.
Okay, well, first what I did was I took 52% and I moved it over 2 decimal places to make it into decimal, 0.52, like that. And then I multiplied 1,038 by 0.52 to get the total number of people, which was 539.76. And then what I did was I rounded it to 540 people, being as you can't have 539.76 people.
Great job. So I guess that means it's my turn now. So let's go ahead and move on to the second one that I had mentioned, and we will look at the fact that among the 1,038 surveyed adults, 52 said that secondhand smoke is not at all harmful. What's the percentage of people who chose not at all harmful? Well, for this one, what I would want to do is say 52 out of 1,038. What would that be? Well, that's going to be, we're going to round off a bit here, so it'll be approximately equal to 0.05. Moving the decimal point over, as we just mentioned, I'd move it over 2 places to see that that's 5% of the people who chose not at all harmful. So that was 2 examples just to get comfortable with percentages because they will come up quite a bit when we're working with statistics. But now I want to move back to another type of problem that you might encounter when you're looking at samples. And that can result from loaded questions. So in loaded questions, the survey questions can be loaded or intentionally worded to elicit a desired response. In other words, you can sway your question to make it sound that people would want to respond positively or want to respond negatively, or you can try and keep that question as neutral as possible. Tally, can you think of an example of some kind of question that I could maybe word neutrally, and then I'll try and show how to word it one direction or the other?
How about, did you vote in the last election?
That's actually a pretty good way to word it. Just naturally, people are going to respond pretty equally in that case, or pretty truthfully. One problem with that question actually is elections in general. People know they should vote and don't always, so they might respond positively, but you're not really trying to sway them. However, if I said something like, oh man, I got into the polls early this year to make sure my vote was there, to make sure I didn't run out of time. Did you vote? What do you think they're going to say?
Most people would assume that you want them to vote too, so they'd say, yeah, I did, even if they didn't.
Right. And then you've always got the person who says, oh, what difference do elections make? You know, it never comes out. I think they're rigged, so I didn't vote. How about you? Something like that. You know that they're going to respond negatively in that case. So that's how you can word a question differently in order to try and get the kind of response you want. If we move on from there, we can also see that the order of the questions, if you put questions in a certain order, sometimes survey questions are unintentionally loaded by accidentally putting them in a specific order. For instance, you might have the first question is sometimes answered differently than future ones. Or I don't know if you've ever taken a test or something, and one of the questions you don't know, but you get onto one that's 3 or 4 down, and that triggers something from the first question, and you can then remember something or change your mind. That can be true with survey questions too. Some information that's unintentionally inserted into a question earlier changes your knowledge, so you answer a later question differently. So in that case, the order could affect your results. Now, a very common one is refusals. When people are asked survey questions, some just firmly refuse to answer. Maybe you haven't ever done that, have you?
Well, from time to time I get something in the mail or some phone call and I pretend that I'm busy. I just don't want to answer what they are asking.
I have to admit, I do that too. I actually get a lot of surveys at work. And lately they even start saying if you fill this out, you'll get a gift, or we'll make a donation to your favorite charity, or we're going to enter you in a drawing if you respond, things like that. And I have to admit that I still get rid of them sometimes. And so all those different things can be problems when you're trying to get an accurate sample. Another thing we could take a look at is correlation and causality. And that says that when we find statistical association between 2 variables, we cannot conclude that one of the variables is the cause of or directly affects the other variable. This is actually rather a technical issue. It'll come up in a great detail in a later chapter, so we're not going to talk about it too much here. But what I do want to say is just because there's some kind of relationship between data doesn't mean that one causes the other or one does some particular effect on another. But otherwise, if we move on, then we've also got the idea of self-interest studies, and that's when studies are sponsored, sometimes sponsored by parties with interests to promote. In that case, I don't know if you remember, this is one that always comes to mind for me. The idea, remember those Coke and Pepsi taste tests or something?
Yeah.
Do you remember who used to sponsor those?
I think it was Coke, but I don't remember.
Well, who used to win? How about that? Who used to win? Okay, well, if Coke won the taste test, then that means that they probably sponsored it because Pepsi wouldn't want you. So anyway, that's the case. Both, for all we know, both companies might have been having these taste tests going on, but they're only going to post the results if they're positive for their company. And they might even kind of try and have leading questions like, was this one better, or, whatever. So you really want to be careful about which company or who is sponsoring the study that you're reading about.
I see. So obviously the company who would benefit the most would probably, release their information, or somehow they use some kind of statistical technique to make their information, be to their benefit.
Right. Like if you were looking at a study about peanut butter sandwiches, would you want to listen to one that had been done by Jiffy or Welch's or by an independent company? And so that's what you'd want to keep in mind, is who is actually conducting the study. And that sometimes it's hard to find that information. You really want to look and find out who came up with this study.
Yeah.
Oh, another thing to look at, well, actually, I'm going to go through 3 more different types of problems, and I'm going to try and trick you with some questions. So let's look at precise numbers. When a precise figure is used, many people incorrectly assume that it's also accurate. Or with partial pictures. In that case, claims can be technically correct, but misleading if they do not present the complete picture. Or finally, deliberate distortions, and that's just when results are created without data to back them up. So I think deliberate distortions is pretty self-explanatory. Someone just wants something to be true, so they say so, or write it down, and there actually is no study or anything to back that up. But how about if I told you that there were 103,215,027 households in the U.S.?
How would you know that's exactly how many there are?
Exactly. That's a great question. I wouldn't. There's no way to know exactly how many houses are in the U.S. because even if you tried to somehow count them all, new ones are being built and old ones are knocked down. They're changing even as you count them. You could not get that precise of a figure. It would be much better to write there are approximately 103 million. Because this number, even though it's a precise number, is still an approximation. So if you round it and use it that way, it accurately reflects the fact that it's an approximation, rather than trying to make people believe that that's an exact number. I have good news for you. Did you know your statistics instructor, she didn't fail anyone last semester?
That's great news.
Oh, I forgot to tell you, she didn't teach statistics last semester.
Oh, well.
That's a case, again, that's a case of a partial picture. No, she can't fail anyone if she didn't teach it. So
I just jumped to the conclusion you gave me all of the information.
Yeah, there you go. So anyway, that's several different types of ways that you can sway different statistical results, things like that. So hopefully now when you analyze different statistical claims, you'll have a better idea of how to look at or look for misuses of statistics as you continue in your studies. And they'll become easier to identify as you continue practicing. That's all the examples I have for you, though, today.